So I'm now going to turn the program over to David Chapa, Global CTO, Emerging Technology Division, EMC. David is responsible for leading a worldwide team of field CTOs who carry out the mission of representing the division's technology direction and solutions. Prior to joining EMC, David served as Chief Technology Evangelist for a company that was here for a very long time, Seagate. Please join me in welcoming David to the podium. So, David, the Seagate piece I totally missed.
You missed the Seagate piece?
I missed the Seagate piece. So we even call that building down across from the History Center the Seagate building still.
Interesting.
Isn't it?
I was with Seagate for about 3 years, I guess it was. And through an acquisition, they owned the company I work for, then they brought us inside. And I was operating a very similar role that I have right now inside their Cloud Systems and Solutions group.
So does everyone know the Seagate building that lives there? Right. Isn't it funny? That's a Pittsburgh thing. I've been here too long now that I know that. Okay. Thank you.
Thank you. Well, good morning. Let me get closer to the mic because you're probably recording all of this, right? Yes. So my name is David Chapa. I've been with EMC for about 6 months. And my background is in, obviously, IT. I've been in the industry for about 30 years. I started out as a nighttime backup operator, backing up a weighing system, and backing up to 288 meg disk packs and 9-track reel-to-reel tape. And so for some odd reason, I really enjoyed backup. And I stayed in that technology that grew for many, many years. And as I started to see people move away from, backup and away from data management, I was staying in that track because I knew that there was something more valuable about the data that I was protecting, but there was something about the data as it was sitting on these endpoint, dead-end repositories that had to change so we can get better access to that data. And so here we are today, and I apologize if I make this thing loud. I move around quite a bit, so this may not be a good idea for me, just letting you guys know today. So I'm going to talk to you about big data exposed. I worked for another storage company, and it was about 2007, 2008 that I first heard people starting to use big data as a regular phrase or a regular term in conversation. And I asked the question, because I was always the one being very inquisitive, what does it mean? And I couldn't really get a consistent answer from anybody of what big data meant to them. But this was 2007. Well, big data could mean a lot of things. And that's what I'm going to try to do today, is expose a little bit of what I believe big data is based on the number of years, 7 years, 8 years now, that we've been calling it big data. And I want to thank you very much for this presentation. I hit the wrong button. So, how about that? I thought I was going to be creative with this one. I like big bites, I cannot lie. Unfortunately, as I Googled that, I found out that I was not the first one to come up with that. Apparently, the computer HAL on the Discovery Space Shuttle tweeted this out by itself, that it liked big bytes and it cannot lie. So, and I think when we think about big data, we think about large files or large big images. And that's what I'm going to talk about here is it big files? A company I used to work for, that was a big thing that they talked about, was it's big files. It's really huge files. It's not necessarily just big files. It could be a big number of big files. But it's not just the big number of big files either. It's a big challenge. Big data is a big challenge. I think because we still haven't been able to really identify and define what big data really is. But big data really, to me, is a big collection. It's a big collection of files. Small files, large files, unstructured data, structured data. Big data is everything that we're collecting. And again, I talked about my background as a backup recovery guy. All that data that goes to an endpoint repository has value, but we could never get access to it because we put it someplace that we would call safe and not be able to really monetize that data for other purposes. And so the big collection of the data sets, the files, the large files, the small files, that's what we call volume. Get this to build out here. Now we have these new sources of data that we're getting data from. And as we are looking at the information that's coming into our repositories, we're getting new and interesting data from John Deere tractors. We're getting them from a Nest. We're getting them from drones. We're getting them from anything, even a dress that actually will tell you what mood you're in. All that data is being collected. And the data is being collected in everything. How many of you use the app called Waze on your smartphones? I mean, not Big Brother here, but all that data is being collected. I used it when I drove from Newark here. And en route, it actually rerouted me based on analytics, based on traffic patterns. And it gave me a faster route based on what it knew ahead because of all the other Wazers that were out there reporting. That's all big data. That's all great analysis for me. And so there's new sources of data that's coming in. That's called variety. We have a variety of new sources of data coming in. We have a variety of new opportunities to analyze the data. And then we've got data where we're starting to analyze voice. We're going to analyze the ticker. We're going to look at financial data, information in logs. I'm an old Unix guy, so I've been doing big data for a long time. Because I used to write scripts that would tail files and would look for patterns inside those files, and then I would create other files that would allow me to analyze those files to see what we were coming up with. That's called analytics in Corn Shell back in 1988. That's big data. This is big data. This gives us insights because we can do it faster. And when you go talk about data insights or big business insights, that's our velocity. So we've got volume, variety, and velocity are the three things that really make up big data. And you've heard this, I'm sure, from a lot of different people. But the key thing about big data and what makes it interesting is actually extracting the value for us. What can we do to extract the value from this data that we're keeping for ever and ever and ever? And oh, by the way, as a backup recovery guy, one of the things I tried to do was to get people to look at the data they're collecting and make sure they're deleting the data that they need to delete for the right reasons. Because when you keep data too long, sometimes that will expose you. And I have a long story about one of my clients in Chicago who is barred from trading for life. And I can tell you at break sometime. But you've got to delete the data that you don't need anymore. But you also have to keep the data so that you can actually monetize it. And how do you make those decisions? Well, thankfully, so many people have been afraid of deleting data that today, now we have the tools and the tool sets to really make something of value out of that. I mean, you still might go to prison, but you got to make sure you delete the data that you need. And so that allows us to analyze the data. And that gives us the ability to do something different with our repositories. Creates a huge opportunity for us. So looking at this slide, and I apologize, I keep on looking side to side because I can't see my slides and I don't have it memorized. I'm too old for that. But who can tell me what this number is? This is a 1 followed by, I think, 18 zeros. Anybody? It's a big number, right? So that's called a quintillion. Did someone say quintillion? Okay. Well, I had $100 in my pocket for you if you did. And when you call that, when you put bytes after it, a quintillion bytes, that's an exabyte. That's big. It's big. How many are operating with an exabyte of data in their data center today? Okay, I had another $100 for someone who had an exabyte. IBM did some research. Do you guys mind if I take this out of the stand? And thank you. I'm going to get a little rock star on you. So IBM, they're not like this. IBM did some research about 2 years ago on the amount of data that we're creating every single day. According to them and their research, we create 2.5 quintillion bytes of data every day. 2.5 quintillion bytes of data every day. Now, we all have smartphones. I have 2 teenage kids. They create a ton of data. I create a ton of data. I looked at my phone last night because some apps weren't updating. You know, you go to the App Store, you say update all, and you go to sleep. Well, some weren't updating. And I found out because I was running out of space. And if you go to your smartphone, especially my Apple iPhone, you can see which apps take up the most. Guess which one takes up the most space? No, not Facebook. Although that could be true with me. My text messages. The messages. I get pictures of my son from my wife because I travel about 90% of the time. So that's how I see my son grow up, unfortunately. I see it through pictures. I get links. It was almost a gig of storage. So we're creating data, 2.5 quintillion, and this is 2 years ago. And that equates to 2.5 exabytes of data on a daily basis. It's massive. And so how do we manage that? How do we manage to get good information from this data? And the good news is we can actually look at this data, this big data, the variety of data, the velocity of data, the volumes of data, through the different tool sets to actually extract some great value from it. And that extraction of value allows us to look at different opportunities in our business. So I'm sure everyone has seen a slide like this or this slide. This is the IDC study on the digital universe. So I gave you a snippet of what IBM looked at 2 years ago and how much we're creating on a daily basis, 2.5 quintillion bytes of data. Now we're taking this and looking at the entire digital universe and what is our growth expectation going forward. Well, IDC is saying it's going to be massive. I think it says 44 zettabytes by what is that number up there, 2020? 2040? I can't see. Thank you, 2020. That's massive. Again, big collection of data, large files, small files, structured data, unstructured data. By the way, the majority of that growth is all in unstructured data, which again is the opportunity for us in looking at how we can extract value from that data. So as we look forward, we got 30 billion devices. When I check into a hotel, and this was actually about 3 years ago, you check in the hotel, they give you, a Wi-Fi code, you can log in, get free Wi-Fi, you pay for it. About 5 years ago, I had 2 or 3 devices, and I was blocked out. I can only do 2 devices. And today, I can get all my devices, and when I'm traveling with my family, I can get their devices. We can get 6 devices in a hotel room. At my home, I have probably, I think I counted up, I had to expand my DHCP, but I think I have about 22 devices at my home that are connected via Wi-Fi. So we have 30 billion devices that are connected, that are creating data, that are using the data. 7 billion people and 1 million plus new businesses, all creating data, all in need of value and that opportunity. So I kind of try to think about, how really to define what big data is. And this is the best. I'm not going to read the whole thing to you here. But this is the best that I can come up with. And the last paragraph, I think, is the last little snippet. The new technologies like Hadoop and Spark allow you to analyze the data in different and meaningful ways. So when I was talking about me writing Unix scripts and tailing files, back in 1988, that was meaningful. That was actually kind of cool. I could create a whole series of new data. And by the way, that's the other thing we need to understand. When we have data that we want to analyze, we create new data sets. And those new data sets we can also access and create even finer granular data sets to give us more value. But when I was doing that in 1988, that was meaningful. That was compelling. And we could actually use that information and use that data to change what we were doing as an organization. And today, with Spark, like technologies like Spark and Hadoop, you can do it much faster. You can create these repeatable schemas and do it much faster on larger collections of files. So I think from 2007, when I first heard the word big data, to today, I've been seeing this whole thing, this big data sprawl. And we keep data. We know we're keeping data. We have more and more data. We saw the IDC growth chart. You listened to me talk about IBM, 2.5 quintillion bytes of data every day. And we end up buying more silos of storage or having different repositories of storage. Now, from an EMC perspective, thank you. But is that really convenient for you to buy silos and silos of storage? Or is it more convenient to you to actually consolidate this? You know, there was a thing when virtualization started to become more mainstream. We called this the virtualization sprawl. So VMware was everywhere. I could create a virtual server in seconds, and then I had to do something with it. I had to actually protect that data, or I had to manage it better. Well, I'm seeing the same kind of phenomenon with big data and with data environments. The sprawl is happening. You've got NAS, you've got SAN, you've got different types of storage silos. That they're all independent, all contain valuable information or valuable data that you could turn into usable and actionable information. But it's a little more difficult because they're not in a unified fashion. And so IDC, again, about 3 years ago, was really looking at this, and they came up with the concept of a data lake. They're the first ones that said, you know, if customers could actually consolidate all of these tiers of storage into a common location, a data lake, a primary data lake, where they can get access to all that information, irrespective of where it was created and how it was created, then there can be more actionable opportunities for those customers. And so we saw a lot of people, a lot of customers adopting this idea, right? Consolidation is great. We saw that with VMware. Wonderful. We had a great consolidation effort over the years. We're still seeing that. But now we need to see storage consolidation so we can get to the value discussion that I was talking about earlier with big data. We got to be able to get to that data more quickly, because analyzing the data, getting the results, means in some cases money, or it means a faster cure to a disease, or it means I can make shifts in my business that really affect the outcomes that I'm looking for. So let's talk about a little bit of the change that we're seeing in the industry. I've got several logos up here. Tesla is a car manufacturer, right? They're actually more of a software manufacturer than anything else. If you own a Tesla today, you can actually update the firmware on your car through your app. That, to me, is more of a software company with a great base of technology that's hardware. GE, their engines, the planes, and I fly, to date, I've flown about 155,000 air miles. Those engines have so many sensors, and when those planes are on the ground, all that data is being collected, which explains why I'm delayed sometimes. And they analyze that data. They can actually find out in near real time, do we need a part? That engine can go another 10,000 miles. And so when it gets to New York, we're going to have that part in depot. They're collecting all that sensor data, and they're analyzing it, and they're making decisions for the right business outcome, which number one is safety. You've got Nest that can actually adjust your temperature based on your activities. All this data is being collected, and all this data is being analyzed and used to create either a better customer experience, or a higher level of safety, or create more fun with a Tesla car that you can download, you can update, and you can have a better experience with the data. All these things are critical, and that's the way our world is changing. So we got the variety of data, we got the velocity of data. I mean, the Waze example is a good example. All that data is being collected to make my experience driving from Newark to Pittsburgh much more enjoyable. It couldn't stop the rain, though. I tried. So in the past, we had, like I was talking about my scripts, right? So we had basically one-dimensional operation. I can go and look at a file. I can look for patterns. I can create a report. This is what I'm seeing one-dimensionally. And it's been great. A lot of us have been doing big data too, by the way, and analytics in spreadsheets. Lotus 123 in the late 80s, early 90s. Excel, pivot tables. And I think some of us are probably still doing that. I know some accountants that I work with that still like pivot tables and do their analysis that way. And that's all well and good. But now we want to take all of these other sources. We want to layer them together and do things that we wouldn't be able to do in the time frame allowed in a pivot table to really make meaningful decisions for our business. So this is kind of the analysis here that I'm looking at. So where we are today, so business intelligence. Makes a lot of sense. We can look at the data. The data's been there for a while. We run through some scripts. We run through a pivot table. And we come up with some, hey, this is what happened. This is why it happened. And we can make some decisions. And that's great. We need that. But we also need to be able to go beyond and say, okay, now let's talk about data science. Now that I know what happened, why it happened, now I want to look at how things will change. What are some of the predictive things that I can do? Again, the Waze app. It predicted that I would be delayed by 20 minutes if it kept me on that same route. And so en route, it rerouted me. And it saved me 15 minutes. That's predictive analytics. That's using the data that's around you to make good, actionable decisions. I got to watch myself. The last time I did this, I fell off the stage. Yeah, no, I won't. I felt my foot going like, oh, this is not going to be good. But actionable, so predictive analytics, that's what we can start looking at. Financial institutions, Monte Carlo simulations, looking at genomic research. There's the London Genomics Center. Their goal is to sequence every single citizen. And they're starting in the Ormond Street Children's Hospital. So every child that comes in that has some type of terminal disease, they're doing the sequencing on their DNA. And Harvard Medical subscribes to that data. It's all anonymized. They subscribe to that data, and they run through analytics. And they look at a lot of things. They look at the type of disease. They look at the type of medicines that have been given to the patient. They look at environment. They look at age. Look at weight. They look at a lot of different things. And they send back their analysis. We suggest these patients with this type of strain should have this type of medication because this is the result when we see and go through our analysis, we cut through the data. So that's predictive, and that's meaningful, and that's very actionable. So there's ways that we can use this data that we've been storing forever now and really get some benefit from it beyond just the what happened last quarter, why did it happen, and what do we think we might be able to do about it, to the behaviors of all the data we've been finding in our structured and unstructured data, as well as all of the data around, the information around that data tells us certain things that we can do differently and look for quick results. So it allows us to make agile decisions in real time. So I stole my own thunder when I said that. So big data is more than just, it's more than just the big files. It's about agility. It's about being able to make those decisions and get the insights as quickly as possible. That's what big data really is all about. It creates opportunities. It gives you the ability to have sharper insights into your business. So we had, let me go back here. So we have the product. So this is the John Deere tractor. And I forget the number now, but there's a number of sensors on this tractor that they are using to analyze. So they, bigger industries, bigger farming industries will follow the GPS on the tractor. They'll look at all the sensors on the tractor. They'll see the direction. They'll track the time of day that they're either collecting, or they're harvesting, or they're plowing, or doing whatever, and they will make decisions based on weather, right? So environmental, based on the soil, based on a number of different aspects, and say, you know what, we should start at 5:45 a.m. instead of 6:45 a.m. because we'll get a better yield. And it's really quite amazing. We get down to that level. I was talking to Rod last night at dinner, and there's one of his customers that says, look, you know, we have all these bakeries, and we have all these refrigeration units, and we have several stores. We want to do analytics on the power consumption, and we want to match that to the cooling, and we want to see if we can save power by analyzing the sensors that come out of this. That was their one goal, to save some energy by analyzing the refrigeration as well as the power consumption. There's lots of things you can do with big data. It's just a matter of asking the question of your data. And I think that's the biggest challenge that I have seen, is not really knowing what questions to ask of my data to get the information that I need to be more profitable or more actionable in my business. So the new opportunity, the context, the intent, and doing it in real time. It's kind of what I was just talking about. In what context do I want to get this information? What do I want to do with it? What's the value there? And honestly, if you don't know, then there's a chance to talk with any of us here, talk with me. We can give you some ideas. There's lots of customers have lots of case studies and use cases that they have gone through. It can be as small as, how do I reduce the power consumption of my refrigeration units and save some money, to what's the best time for me to send out my tractors so I get the best yield of my crops, to how can I help cure cancer? So the progression here of big data. So generate and retain the data as much as possible. Remember I said before, delete the data that you don't need? Sometimes we got to do that from a compliance perspective. But there's a whole lot of data, sensor data, machine learning, that we need to keep so that we can actually analyze that and use that. That's very valuable. But collect it. Decide what you want to do with it. And then build a schema that will allow you to kind of pull that out and extract that. There's this slide here is kind of interesting. What's driving it? Of course, data growth is driving it. We knew that. But we're looking at things that allow us to do that, is the effective storage. So now, instead of putting things to a dead-end repository, I can keep things on disk, because storage is getting more effective, or as others would say, storage is getting cheaper. So I can keep data longer spinning. We got compute opportunity, limitless compute in some cases. So I can do more, and I can actually scale my compute and my storage independently, so that I can get the best of both worlds. Real-time technologies, I was talking about Spark. There's other technologies that will be coming. Doing this in an all-flash type of rack scale solution allows you to get to those results a lot quicker. And I think that the big thing here is, where do you start? And I think you got to look at the data that you want to collect, the platform that you want to use, and the outcomes that you want to achieve. Those are the biggest things. What are the outcomes you want to achieve? Get past the easy button here. So build your apps the right way. Make sure you're asking the right questions. Employ the expertise around you. So if you're working with us, you're working with a partner, you're working with somebody, another vendor, ask the questions of their experts. We have, in our Brazil Research Development Center, we have about 14 data scientists. And I had an opportunity to spend some time with them down in Rio a couple months ago, and was really impressed with what I saw. This team has been working on several very, very large projects. And one in particular is, we call it smart cities. Smart cities actually will collect data across cities. We're doing actually this project for a country, so go figure. But it's they're collecting data from all over, looking at video surveillance, so video streaming coming in. We're looking at sensor data on the streets. So as cars are going and driving by an intersection, as pedestrians are hitting the walk button, they're looking at parking, they're looking at bus transportation, they're looking at trains, everything. And they're making an analysis based on the needs of the people, the needs of the citizens. Do we need to increase our bus routes? Do we need to redirect and get parking over to the south side of the city? Or do we need to have something with law enforcement because there is a crowd of people starting to build and there's video surveillance is showing us that there's activity? There's lots of things that are going on in the analysis of the data. And that takes a data scientist to really think through how you extract that and how you make that turn that into a meaningful, actionable information. So my point here is, data scientist is not just a fancy little name. There's some smart people that are looking at data differently. And I would really, really strongly suggest, if you're not sure where to start there. Get a workshop and have people talk to you about what the opportunity is for you and how to look at the data a little bit differently. Or I can come in and write a Unix script for you. Just kidding. So ingest your data, store your data, analyze it, extract that value, and then act upon it. That's really the key tenets of big data. If you're going to keep it, let's use it. And if you're going to keep it, let's keep it somewhere spinning so we can make sure that you can get to it and get those results. So that leads me to the last couple of slides. A data lake 2.0. So data lake 1.0, let's say, was let's consolidate all of our work streams into one primary source or origin of truth. Well, as we look at our environments today, all of our data isn't necessarily inside of our data center. It's also outside our data center, at the edge, remote office, back office, home office, on the road, like I am most of the time. And so we got to be able to get that data back somehow, or at least create some type of unified platform where we can communicate back and forth, analyze the data in the field, analyze data at the remote office, or at least push that data into our core so we can provide that same level of service and opportunity. So when you're looking at big data, you're looking at analytics, this isn't just an IT function. This is a team sport. Again, I'll go back to data protection. As I was a backup guy, the backup guys didn't really talk to the business guys. It was always, well, we're just going to back this up. We're going to back it up to tape. And if we run out of tape, we'll buy more tape. And we shifted. So from the 80s into the mid-90s and in early 2000s, we started to shift. And the backup guys started to really ask different questions. And so what I'm seeing today is that it's the storage guys and gals, who are looking at asking the different questions. We're not just about provisioning more storage for you now, where, remember, I was the backup guy, I was provisioning more tape for you. But we're asking the questions, well, what's your end goal here? What are you trying to accomplish? I mean, you're going to get more storage, we're going to provision more storage for you, but what is it you really want to do? And so everybody has to be on, maybe not on the same page, but in the same room. Have the conversations with the business unit leaders. Have the conversations with IT. Don't be afraid to ask those questions. I think that's the biggest thing that I have come across in the last 8 years is there's a little bit of a fear to start a storm when you ask the questions that are the hard questions. But that's where you yield the best results, I think, and you can do that in a solid working relationship with your team. So, enterprise data lake solutions, they are available today. You can do it today. We've been doing it for a long time. As was said earlier, I represent EMC in the Emerging Technologies Division as the CTO. Isilon has been the, I'm not going to say de facto standard, but it's been one of the standards that people have been using and analyst groups have been referencing as the enterprise data lake. So the key tenets around OneFS is you have one file system, multiple protocols, or multiple access points to get data in and get data out. And chiefly, the most important part, I think, of this type of data lake is that you have a native HDFS or Hadoop file system protocol. So there's no screws you got to turn. There's no installs you got to go through. It's a convenient, easy to use solution. All the data resides there. If all the data resides there, you don't have to create multiple copies onto a different cluster, which a typical Hadoop infrastructure requires you to make 3 copies just because of how it's designed. And we mitigate that through OneFS. We also mitigate all of the other ancillary requirements as far as having multiple data nodes and name nodes. We manage all of that. And we have over a petabyte of storage under management across our customer pool right now that are using this for analytics, for Hadoop. We have, I don't know the number for Splunk and for other types of analytics engines, but Hadoop is a big one for us. And we see a lot of customers leaning that direction because of everything I've been talking about. So I think I either went over my time or I'm right on my time. Okay, thank you very much. I appreciate your attention.